Friends, we are very happy to inform you that e-modules are prepared for B.Ed program at Telangana by the School of Education, Osmania University under Pandit Madan Mohan Malaviya National Mission on Teachers and Teaching Scheme MHRD New Delhi. It's indeed our pleasure to share with the teacher educators and the prospective teachers and get maximum benefit out of it. It's a first of its attempt by us. We continue to add many more such lessons to share with you all.
Good morning everybody. My name is Dr. Shrivalli from School of Education, Osmania University. Today we'll be dealing with the topic concept of mathematics. In this journey of concept of mathematics, there are 4 phases. The first phase is introduction. The second one is meaning and nature of mathematics. The third phase is concept formation and concept assimilation. The fourth phase is formation of mathematical concepts. We'll start with the first phase, phase 1. In this, we'll try to find out what is the main goal of maths education. What is the main goal of maths education? The main goal of mathematics education in the schools is mathematization of the child's thought process. There are many ways of thinking, and the kind of thinking one learns in mathematics is an ability to handle abstractions, and that leads to an approach to problem solving. To achieve this goal, there is a need to develop the inner resources of the growing child. In developing the child's inner resources, the role that mathematics plays is mainly developing the logical thinking skills in a child. Since mathematics helps in training and disciplining the mind, and also in developing the powers of thinking, reasoning, and it is a mental tool for study, it has its applications in other branches of knowledge. Mathematical skills and their applications form an indispensable tool in our daily life. Mathematics is a complex system of concepts and not merely a collection of facts. Mathematics is a complex system of concepts and not merely a collection of facts. Maths concept is a why and a big idea of maths. The student should be helped to have a carefully chosen set of mathematical experiences through teaching in order to help him form a new concept. If the concept in mathematics is at the foundation level are clear, interesting and enjoyable, only then mathematics becomes automatic once the child grows up. The clarity of fundamental concepts and procedures also helps the learner in mastering the difficult concepts of higher order. Thus, there is a necessity of teaching more enriched mathematics in a better way. So this is all about how we can do mathematization of a child's thought process. Now let's move on to phase 2. In this we'll be learning about meaning and nature of mathematics. Let's move on to the second phase where we'll be learning about meaning and nature of a concept. The term concept is multi-ordinal. What is multi-ordinal? It takes variety of meanings. The dictionary meaning of concept is a thought, a mental image of anything formed by generalizations from a particular idea. Concept is also a generalized idea about, it could be an object, person, events or experiences. We'll see the other definitions of a concept. The other definitions are as follows. A concept is an inferred mental process. It has a common name of class of objects, events and processes. It is a mental construct or a mental image of an object. It is an abstraction of inferred experiences or information processing. Generalizations under which fragments of knowledge can be encapsulated. Concepts are a kind of subject matter, and we know that mathematics is a complex system of concepts, and mathematical concepts are only one class of concepts. Development of concepts is a basic in mathematical learning capacity, since by the means of concepts, other kinds of subject matter are learnt. Now we'll go on to the third phase where we'll be understanding concept formation and concept assimilation. Concept formation. Concept formation is a type of discovery learning involving underlying psychological processes such as discriminative analysis, abstraction, hypothesis generalization and testing, and again generalization. Concepts are among the first thing learned by the children. They mostly learn concepts through concept formation method. In the concept formation, children observe many examples of the object about which the concept will be formed. Follow the processes stated above and then finally generalize to arrive at the concept. Now we will see what are the steps involved in the concept formation. There are different steps that are involved in this process. According to Hilda Daba, there are 3 steps. First one is identifying and enumerating data that are relevant to the problem. This is called as observation. Next, grouping data according to some basis of similarity. This is categorization, and then developing categories and labels for the groups. This is conclusion. Now we have seen concept formation, we will move on to concept assimilation. Concept assimilation is a process of taking in and fully understanding information and ideas. Concept assimilation is typically a form of meaningful receptive learning. Concept assimilation is typically a form of meaningful receptive learning, willing to consider or accept new suggestions or ideas from others. In this, the definition of concept is initially presented, followed by exemplifying and paraphrasing it. It involves active cognitive operations. The learners go through the same process of differentiating hypothesis, generalizing and testing, and again generalizing before new meaning emerges. Concept assimilation is more appropriate strategy to teach relational concepts like transpose of a matrix, inverse of a matrix, congruency, etc. Relational concepts are concepts which are defined in relation to another concepts. Transpose of a matrix exists only when a matrix is given. Now we have understood what is concept assimilation. We will move on to the phase 4 about formation of mathematical concepts. Mathematics is an exact branch of science that is organized and systematized. It is a science of quantity, measurement and spatial relations. Now we will see an example of a concept. We will take here a parallelogram. The first step will be identifying and enumerating data that are relevant to the problem. That is the first step, that is observation. So children, as the students are asked to draw some quadrilaterals on the board, and the students come up with 4-sided closed figures. In the phase 2, grouping data according to the basis of similarity, which we call as categorization. The teacher asks them to classify the given quadrilaterals into 2 tables. They put it into 2 categories. We will see what are those 2 tables. The students are to identify the special features of quadrilaterals in table 1 and that are different from the quadrilaterals in table 2. The students notice that quadrilaterals in table 2 have opposite sides are parallel. They also have the measure of angles as 90 degrees. Then they are posed with one more question as to whether all the angles in the figures are 90 degrees. The students look deeper and state that some of the quadrilaterals have the angles equal to 90 degrees. Further, they are posed with the questions about opposite sides are equal and parallel. The students state that figure 5, 9, 10, 11 have opposite sides are equal and parallel. In the step 3, developing categories and labels for the groups. This is concluding stage. What can be concluded about the figures? All of these figures are quadrilaterals. Both the pairs. In step 3, developing categories and labels for the groups. This is concluding stage. What can be concluded from the above figures? All these figures are quadrilaterals. Both the pairs of opposite sides are parallel. It may be concluded that a quadrilateral in which both the pairs of opposite sides are parallel is known as a parallelogram. Now let's think about mathematical concepts. We all know that why they are different from each other. Now algebra is different from calculus and similarly geometry. So algebra, calculus and analysis, geometry and topology, combinatorics, number theory, logic, dynamical systems and differential equations. Similarly, we can come up with several illustrations of mathematical concepts. I hope this concept is clear to you regarding the concept of mathematics. Now let's wrap up this session. What have we learned? We have learned about the main goal of mathematics education in school. We have learned the meaning and nature of a concept, the general process of concept formation and concept assimilation, the formation of mathematical concepts. In the coming classes, we will be learning more about different strategies of teaching maths concepts. Thank you.